Now, after understanding how the controllers can be onboarded, we need to understand the concept of tunnels. So, in between the controllers, the data can be sent before creating tunnels. These controllers will make tunnels automatically. The tunnel name will be DTLS tunnel. So, DTLS tunnels can easily be created in between the controllers like vBond to vManage, from vManage to vSmart, and from vBond to vSmart. DTLS basically stands for Datagram Transport Layer Security, as it works at layer 7. At layer 4, UDP protocol will be used and the port number will be 12346. Now, it is very important to understand the concept, because while troubleshooting the controllers, if you are onboarding controllers and if they are not forming the DTLS tunnel, the port numbers are very crucial to troubleshoot. Okay, in between the controllers, can we also form the TLS tunnel? The answer is yes. In between the controllers, the TLS tunnel can be formed. TCP protocol will be used at layer 4, so that means it is one of the reliable protocols, and the port number used to create the TLS tunnel in between the controllers is 23456. So, in this diagram, what you can see is in between your vBond and vManage, we can see that DTLS tunnel is created. In between vBond and vSmart controller, DTLS tunnel is created. And in between vManage and vSmart, DTLS tunnel is created. It also depends the number of transport which you are using to form the tunnels. Over here, in my example, if all the controllers are connected with one transport, one tunnel per controller can be created. If one controller is sending, for example, vManage is sending some data to vSmart, that data will be transported in a secure tunnel, which is DTLS or TLS tunnel. Now, after understanding the onboarding process for the controllers, now let's talk about the routers. In SD-WAN, at each branch site, you will have to place physical routers or virtual routers. Yes, you are right. Now, the routers can be physical or they can be virtual routers. But in SD-WAN solution provided by Cisco, there are two operating systems. The one is Viptela operating system and the second is Cisco operating system routers. If you talk about Viptela operating system routers, the physical routers available are ISR series 1100, 4G, 6G, and many more devices. But when I talk about iOS operating system routers, the physical devices which you can purchase from Cisco is ISR 1000, 4000, and ASR 4000 series routers. If we talk about virtual devices, virtual routers, in Viptela, we have one option of V-Edge routers, and in Cisco, we have one option of C8000 V series device. Now, these two devices are virtual, so that means you will have to download the image from Cisco portal, install on one of your VMs or physical servers or cloud, and then what you can do is, and then you can use these devices as routers. Now, one question in my mind is why I need physical. Okay, physical servers are fine. Why I need virtual routers? Come on. Let's take one example. You have a branch office. This branch office is a small branch office. You already have a physical server in this particular branch office, and you don't want to maintain an extra hardware device. What you can do is you can take the connection from your ISP to the server, and on this server you can install one of the virtual images of routers. If I talk about the operating system of Cisco, the operating system is iOS XE operating system devices which are available. And if you want to run these virtual device, this Cisco device, In the SD-WAN mode, in that case, you will have to change the mode of your particular router. For example, let's say I have a router. This router is C8000V device, or maybe let's say it is not a virtual device, it is a physical router. Physical router, let's say ISR 11, not 1100, 1000 series device. Okay. Now, this router will be by default in a mode which is known as autonomous mode. Now, in autonomous mode, if you want to change the mode of your router, if you want this router to be working as a WAN edge device, in that case, you will change the mode to which mode? Controller. Okay, that is right. Now, what is the difference in between these two modes? Autonomous mode will make your router working as a traditional router, but controller mode will make your router work as a which device? As I told you, WAN edge device. Okay, basically, WAN edge devices are the routers which can integrate in the SD-WAN solution or in the SD-WAN fabric. How will you check the mode? Very easy. When you will take the CLI access of your router, what you are going to do is you are going to check the mode in command. The command is show version. In show version command, you will come to know about the mode of your router and how can we change the mode. Very easy. In the enable mode or in the privilege mode, you are going to run the command controller mode enable. If you will enable this mode, your router will start running in which mode? In controller mode. It is also possible if you change the mode for that particular router, what will happen? Your configuration can be lost. That means the configuration which you did in the autonomous mode can be lost. So after understanding about the series of devices or routers which are available, now what is the process to deploy your routers? Very easy. As you deploy controllers, first you downloaded your image from Cisco site, then you deployed your device on cloud. You can deploy your device on physical server. You can deploy your router on a virtual machine host. Add the image, do the settings. Once the settings are done, restart the device, take the CLI access of your router, and then your router is ready to be configured. Now, as you configured your controllers in the router's configuration, also there are few initial configuration part like you have to configure system, you have to configure the transport interface. Optional is you can configure your management interface. And if you have a LAN connection, in that case, you can connect or you can configure your service side interface. Now, what is service side interface? In the next video, I'll be talking about this. But these are the initial configuration which you are going to do on your routers. After understanding this process, let's move to some of the terminologies which are very important and used in SD-WAN. The first terminology is system IP address. Okay, whenever you are going to configure a router or a controller, what you will do is under system settings, you are going to provide the system IP of that device. Okay, what is the system IP? The system IP is basically a unique IP address to identify a particular device. For example, if I have two routers, router number one and router number two. What I can do is I can provide both the routers a different or a unique system IP. For example, on router one, the system IP address is 1.1.1.1. And on router number two, the system IP address can be 2.2.2.2. Now, you will ask me, okay, Is it similar to the router ID in the concept of OSPF? You got it right. Yes, it is kind of similar thing. In OSPF protocol, a particular router have a router ID. Similarly, in SD-WAN, a router and a controller. I will repeat that again. A controller and a router will have unique system IP address. It is basically to identify that particular device. Next, site ID. When you are going to configure the system settings, under system settings, you will provide the site ID to particular router. For example, you have a site in this diagram. What you can see is in this branch office, I have two edge devices. These are WAN edge device. This is edge 1 and this is edge 2. This is E1 and this is E2. Now, these two routers belong to same site, so their site ID can be same. You can give any number to identify a particular site. For example, I gave the site ID as 10. Similarly, let's say I have another site at different geographical location. Over there, I have a router known as E3. Now, while configuring this router, I will give a separate site ID so that the routers can be identified that they belong to which site. E3 can belong to site number 20 in according to my example. Once we understood the concept of site ID, the next terminology is organization name. Now, this is very important. All your devices belong to same organization, so they must have same organization name. From where you are going to get the organization name, remember the step when you registered your account on Cisco's site. At that particular point of time, you will provide an organization name. It have to be same on all the devices and it is case sensitive. If there is a small mistake, even in space, if you are writing a name and giving any space in between, if it is wrong, then your devices will not be onboarded. What is the reason? The reason is that during the authentication process or during the, I'll say, the certificate process, organization name is checked by the controllers. It have to be same on all the devices. Where you will give the organization name, again, same. Under the system settings, you will provide the organization name to your controllers and to your routers. Next. Now there are two terms, color and encapsulation. What do we mean by color? See, my routers are connected with a transport. For example, over here, E1 and E2 are connected with two different transports. Transport means ISP connections. E1 is connected with a transport, let's say it is MPLS. And E2 is connected with Biz Internet. Biz Internet means business internet. So while configuring this router's interface, at that point of time, I will have to define the color of that particular transport. There can be many colors for a particular transport. If I will give you the names can be something like this. It can be your MPLS connection. It can be your business internet. It can be a internet connection. It can be a gold connection. It can be a public connection, public 1 to public 6. You can name these names can be provided. Now, does it matter? Yes. Now, to understand the colors more in more depth, the colors are basically divided into two types of connections. The one is public color or the public transport, and the second one is a private transport. MPLS in my example belongs to what? It will belong to a private transport. But if we talk about the public transport, it can be your business internet connection. And more transports can be LTE connection, direct internet access connection, and many more. Okay, direct internet access and many more. So you need to define the colors. Colors are important to define while configuring the transport interface of your router. The next terminology which is used in SD-WAN is encapsulation. While configuring the physical tunnel interface of your or transport interface of your router. For example, E1 physical interface is ETH1, Ethernet 1 interface. When I'm going to configure this particular interface, I will define the encapsulation. Encapsulation is important to define. Encapsulation means E1 is going to create a tunnel. Okay, with which router? It is going to create a tunnel with E3 router. Which encapsulation will be used? You majorly have two options for this. In case of your tunnel, or in case of your encapsulation, the two options which are available, the first one is GRE. You can create a generic routing encapsulation tunnel which is not that secured, and 99% of the time on your routers, you are going to configure what? You are going to configure the IPsec tunnel. So IPsec tunnel is majorly created in between the routers so that the data can be forwarded by the routers. Yes. So you are going to define the encapsulation color on the interface. In the configuration later on, in the later videos, I'll share the configuration with you guys. There I'll explain you where we are going to configure the color and the encapsulation on a particular router or on a controller. With this, I will end up this video. Let's meet in the next video. Please don't forget to subscribe and like the videos. Thank you for your support, guys. Bye.
वीडियोस बनाने हैं फिल्मोरा है ना।